Hello everyone. So in this today's video, we will be talking about the roadmap that you should follow for ML, and this will also work for deep learning and basically data science. So if you are looking for a career in this particular field, this is how you should learn. Okay, so these are I'll be showing you what are the things that you will need to do first, second, third, and there, as you can see, 7 things. Okay, so the first thing, let's get started. So the first thing I believe that you should do is some basic mathematics. Okay, so we need to do some basic maths. Okay, I don't know why it's colored red. Okay, mathematics, whatever. Okay, so in mathematics, first you need to do statistics and probability. Statistics, basically your simple as mean and median that you might have learned in your lower classes, and some amount of regression, correlation that we actually saw in the yesterday's video. But even if you have not seen, then no problem, you can do like this. Okay, and also probability, which again includes simple probability, but also some amount of, let's say, Bayes rule and conditional probability. All those things should also be covered. Okay, after that, once this part is covered, you can do a linear algebra course basically. So what you can do here is you also need to just focus on simple things here. Okay, so basic matrix operations. So let's say multiplication and transpose, and you also need to do inverse. Okay, so this is the first thing that you'll need to do over here. After that, you can also do linear transformations. Okay, so linear transformations. Okay, you can check out yesterday's video after this video, so there I have explained it a bit in more detail. Okay, finally, you can over here you can do differential calculus, so that will be useful in, let's say, back propagation and other things as well. So this will be useful. After that, you can do optimizations basically. So you can do stuff like maxima calculation, what is going to be the maxima of a function and minima of a function. So basically you have to also do the functions. Okay, so range and codomain and all those things. Having done calculus, linear algebra, and statistics and probability, the next thing that you would want to do is you would want to start with NumPy. Now I assume programming language is already covered. You are already familiar with programming language, which is Python. Okay, so I think this is already covered. You can also use R, but I would strongly suggest Python. Okay, so in NumPy, what do you need to do? You need to do basic tensor operations. Okay, so you can have to know what is the how you multiply tensors, and not only just multiplication of two-dimensional matrices. You also need to know what is how the multiplication of n dimensional matrix will look like. Okay, so obviously we can't imagine that. So we can't imagine more than 3 dimensions, but we need to figure out a way by which we can understand how matrices are multiplied in higher dimensions. Okay, same thing for dot products of two vectors and matrices and all of that. Basic operations like min, max, mean, cumulative product, and all those things. Okay, so these things are there. So there are many functions. Okay, but you don't have to uh, get fixated on all of them. You just have to learn the basic stuff, and there are a lot of things that you will learn along the way. Okay, again, transpose of a matrix, inverse of a matrix. So these things will be used. This will be used in convolutions. Inverse of a matrix will be used in different places. After that, you also need to learn about indexing. So indexing is basically where you will it's going to be very important. Okay, indexing, because it's going to so indexing is going to help you a lot, because in indexing you basically will learn about how you can take, let's say you have a big matrix, how can you take a subpart of a matrix, or how can you take the last row or second last last column or second last row. So this is very important, and this will only you will only understand, because this is very important when you will be doing deep learning and you will be making your own functions and all those things. Okay, so this is going to be very important there. So you have to learn understanding of access, basically indexing. And you also need to know how to generate random numbers, so np.random.choice. So all these things you need to know, and basic probability of how to implement Gaussian distribution or normal distribution, and how to also implement what to say your uniform distribution and all those things. That will also be in the statistics part. So over here in the statistics parts, you can also mention distributions. Okay, so this is also important. So I think NumPy is already clear. So let's see the third one that you have to do, which is Pandas. Okay, now Pandas is an extensive library, and the things that you need to do are simple, at least in the start. Maybe you can start with reading data frame, writing to a data frame, saving a data frame. So how do you do all of this on a data frame? Okay, and then the simple operations like head and tail. That is, head is used to find show the first 5 rows of a data frame. You can obviously change the n equal to 5 to, let's say, n equal to 10, so it will show you 10 first 10 rows of the data frame, and the same thing as tail, which is going to show you the last rows. Okay, then shape of a data frame, basically to see how many rows and columns are there. How to sort a data frame depending on a particular column or other things, and also how to find unique values and other things, they are also there. There are other functions as well. Okay, so that is there, but starting with this much is okay. After that, you also need to do indexing over here, but here indexing is a little different. You use functions like lock and ilock. These functions are very, very important in Pandas. After that, you will have to do a little bit of pre-processing. You need to learn about missing values, repeated rows, and how to deal with nans and not a number. So these things are important. You can skip this one for some time, but you will have to do it anyway. Once you come up with problems like you are given a column that is having all dates, so how to manipulate that, how to use that, you need to know about rolling windows and all those things. Generally this is important in, let's say, convolutions, or you are doing some kind of a stock market analysis and you want to find trends and all that. In there, this is useful. You will also need to do group by functions, so when you want to carry out some statistics on a group based on certain columns, so this will be useful. And sometimes you can also do plotting with Pandas. For, let's say, for example, you want to do a scatter matrix. Okay, you can do that using scatter matrix. You can do that using Pandas also. But the first 4 and 5, 3 or 4 of them, or let's say first 4 of them are very important. Okay, the rest one you can also do, not do, but you will anyways have to do it later, but it depends on you. Next one, after that you need to do some matplotlib. This will be the shortest amongst all, because you don't have to go very, very deep. You just, because you are not into data analysis and data visualization, you are into data science. So here you just need to be able to plot simple plots. You know what is a histogram, you need to be able to plot a histogram. You also need to be able to plot bar charts, and finally scatter plots. These are just one line functions. Plt dot, let's say a simple plot will be plt dot plot. Okay, or plt dot hist. Okay, so you can do like this also, and so on and so forth. So for the, let's say, for the scatter, you just have to say plt dot scatter and then pass in some inputs. After that, what you'll need to do is, after that, in the fifth, after doing matplotlib, you need to learn either OpenCV or NLTK, but I would suggest learning both. This will be used for computer vision, and this is going to be used for natural language processing. Okay, why these two? Because these libraries, now you don't have to go very, very deep in this. Okay, but these will actually form the basis of your understanding that is required for convolutional neural network, or for natural language, for RNN, LSTM, or mostly transformers. Okay, so these will be very, very important, right? So let's say a CNN, or you want to use some transfer learning using ResNet or something like that. So for that, these will form the basis. Okay, so I would suggest using or learning this before going for deep learning. After doing that, you should try getting into deep learning, but before that you should do machine learning. Yes, machine learning should form the basis of deep learning. You should first understand machine learning, because machine learning is big. ML, a subpart of machine learning can be said deep learning, where we only study about neural networks. Okay, so NN is basically a neural network, so it's a subpart of machine learning, but it's very, very, as the name suggests, deep. Okay, it's very involved, and I would also say it takes time to understand. So in sklearn, how will you start? You basically start with linear and logistic regression, then you move on to MLP, but MLP in sklearn is simple. You should also learn SVM, decision trees, and bagging and boosting. So this will help you with understanding error. Bagging and boosting will help you in understanding error. Decision tree, you can do it. SVM, you can do it. MLP will basically give you an introduction into neural networks, but only simple neural networks. And linear regression, logistic regression, you should do in deep, because this is going to give the basis for error functions and activation functions and all those things. Okay, so this will form the basis. So you should definitely do linear regression and logistic regression, this part. Okay, after that, once you have done all of this, you should go for PyTorch. You should go for PyTorch and not TensorFlow. Okay, I had made one video. I think I'll be removing that video, because I'll make another video where I will discuss why PyTorch is better. I think the debate between PyTorch and TensorFlow is clear, and PyTorch has emerged as a clear winner, but that definitely requires a much bigger discussion. So I'm not going to go here. So I would suggest against doing TensorFlow and Keras, I would suggest doing PyTorch. Okay, but in PyTorch, how you're going to do? First, you're going to do a simple neural network. Okay, so there's an entire PyTorch series on my channel. You can look into that. After that, you can do CNN, then LSTM, RNN. After that, you do transformers. Once you have done all of these things right from 1 to here, only then you will understand LLMs, that is large language models, and generative AI or Gen AI. Okay, now Gen AI is something that I know I have to cover, so wait for that. But once you have done so much, this will only take you so much of time. This is going to take you a lot of time instead. Only after that you are ready, because LLMs are based on transformers. Now transformers are based on, they are an improvement over LSTM and RNN. LSTM and RNN are basically simple neural networks. Now to do simple neural networks, you require all of these things, right? So the idea that I'm trying to give you is that you just cannot get into deep learning just like that. You will have to do all of these things, and only then we'll have the requisite skills to understand deep learning. So I hope you like the video. If you like the video, please like and subscribe. Thank you very much, and bye.